These are the solutions to Melham's Calc 1, exam number 1, solutions for the first test. Okay, number 1, we want f of x minus f of a divided by x minus a. F of x is 1 over x. F of a is 1 over a divided by x minus a. Multiply top and bottom by ax. So ax times 1 over x is a, minus 1 over a times ax is x, over x minus a times ax. A minus x divided by x minus a is negative 1, so negative 1 over ax. Number 2, first I find the slope. So 30 minus a negative 10 divided by 11 minus 3, y2 minus y1 divided by x2 minus x1, that's a 30 there. Comes out to be 40 over 8, which is 5. So the slope is 5. Then I do the point slope form. I chose this one because they're both positive. So y minus 30 equals m times x minus x1. Y minus 30 is 5x minus 55. Add 30, y equals 5x minus 25. And that's my function f of x. Number 3, f of negative 3, f of 1, and f of 4 is 0. That tells me the function is some constant k, which is not 0, times x plus 3, x minus 1, x minus 4. And then to find out the k, I use the fact that f of 0 is 1, which means if I plug in 0 here, here, and here, the answer is going to be 1. So 1 is equal to k times 3 times negative 1 times negative 4. This comes out to be 1 equals 12k, or k is 1/12. So put 1/12 back in here, and final answer, f of x is 1/12, x plus 3, x minus 1, x minus 4. Number 4, f of x minus 4 minus 6, just move 4 to the right and 6 down. Number 5, f of g of x means f of 3x minus 7. Put 3x minus 7 there and there. So it looks like this, 3x minus 7 squared minus 6 times 3x minus 7 minus 1. Multiply it out, 9x squared minus 42x plus 49 minus 18x plus 42 minus 1. Gather like terms, 9x squared minus 60x plus 90. Number 6, I've got it color-coded. You didn't have to color-code it on the test, of course, but it'd be nice if you did. So I have 2 to the x in green, e to the x, e is like 2.7. So in red, I have e to the x. So you can see e to the x is above on this side, which is below on this side. And then 1/2 to the x falls, so it goes like this. They all go through the same point, 0, 1. Number 7, a little bit clumsy, but it still can be done. F of x is c a to the x. Plug in 1, 2. 1 goes here, 2 goes here. So 2 equals ca. 3, 16. Put a 3 here, 16 here. Okay, divide both sides by 2. ca is equal to 2, it says so here. So a squared is 8. A is radical 8, which is 2 radical 2. So put 2 radical 2, plug that back in right here, c times a. So 2 equals c times 2 radical 2. Divide both sides by 2 radical 2. So c is 1 over radical 2, or radical 2 over 2. So f of x is equal to radical 2 over 2 times 2 radical 2 raised to the x power. Number 8, switch around x and y. X is 3y plus 1 over 2y minus 3. Multiply both sides by 2y minus 3. So I get 2xy minus 3x equals 3y plus 1. I added 3x to both sides and subtracted 3y. So I have 2xy minus 3y equals 3x plus 1. Factor out the y times 2x minus 3. Divide by 2x minus 3. So my f inverse is 3x plus 1 over 2x minus 3. Number 9, take the natural log of both sides. ln, ln. That brings the x minus 2 in front. Divide both sides by ln 3 and add 2. So x is 2 plus ln 7 over ln 3. 4 decimal places, 3.7712. And number 10, cosine of inverse sine of x. Call this theta. So ultimately, I'm trying to find cosine of theta. So theta is inverse sine of x, which means sine of theta is x over 1. Draw myself a triangle. Use my SOHCAHTOA. Here's theta. Sine is opposite over hypotenuse, so x over 1. Pythagorean theorem, you get y is radical 1 minus x squared. If you temporarily call that y, Then you have x squared plus y squared equals 1. Solve for y, radical 1 minus x squared. So cosine of theta, cosine is adjacent over hypotenuse. So radical 1 minus x squared divided by 1, or radical 1 minus x squared. And that is the solution key to Milham's Math 251 Calc 1, the first test.